3.2 is going to cover linear functions, and within the word linear is line. So yes, we're going to be looking at graphs, data, relations, and determining if it is going to create a line or if it's not. So our first example is simply a graph. So we can physically see that A is nonlinear and B is linear for the simple reason that B is straight and A is a curve. But if we look more closely, and this is going to help us with future problems, B is a line because it is a constant rate of change. So if I go from one coordinate to the next, it increases by the same amount. I'm going up by 2 on my y's as my x goes up over by 1. Up by 2 over 1. Up by 2 over 1. Up by 2 over 1. And if you remember, we will get to this in later sections. That is the slope. If we look at graph A, it is not the same. I'm going down by 3, right 1, down by 1, right 1, up by 1, right 1, up by 3, right 1. So it is changing at a faster rate at different times, which creates that curve. It's also decreasing and increasing, which creates that curve as well. So we need to use that in order to look at a set of data. So if I look at A, to determine if it's linear or nonlinear, I need to see if it's moving at a constant rate. So for my x values, I'm going up by 3, up by 3, up by 3, which is good. My y also needs to be constant. Down by 6, down by 6, down by 6. So due to the constant rate of change, I can determine that example A is linear. I'm going to analyze B the same way. Up by 2, up by 2, up by 2. Perfect. Up by 7, up by 11, up by 15. So this is not constant, so I would say this is nonlinear. Notice, though, that these are both functions because none of our x values repeat. Last, we're going to look and determine if an equation represents if it is linear or nonlinear. So hopefully this next equation I'm going to tell you, y equals mx plus b, sounds very familiar because that equation represents a line. A few things that you want to notice that's going to help you is that there are no square root symbols. X has no exponent, which means it's to a power of 1, and x is in the numerator. So if I look at example A, y equals 3.8. So this is somewhat in the form y equals mx plus b. It's just that an x isn't written, but I could rewrite this as y equals 0x plus 3.8, and it emulates y equals mx plus b, so this is linear. Example B, due to the square root symbol, that is actually an exponent of 1/2, and we need an exponent of 1 in order for that to be linear. So that is non-linear. Example C, x is an exponent. This is an exponential function, not a linear function. So once again, non-linear. Example D, the issue here is that x is in the denominator. So once again, non-linear. Example E, I'm going to distribute this just to try to simplify. and I have y is equal to 6x minus 6, which is a perfect representation of y equals mx plus b. So that is also linear. And then my last example, E, if I solve to get, F, if I solve to get y by itself, I'm going to subtract x squared from both sides. So I have negative y equals negative x squared. And then I'm going to flip my signs. So I have y equals x squared. Due to this exponent of 2, this last example is also non-linear. It actually creates a parabola when it's a square.